Okay, we talked about how we find the mean of a discrete random variable's probability distribution. Now we need to talk about the standard deviation. So there are two different formulas for the standard deviation. Either one of them will work. I'm just putting them here again to show you what you're not missing now that we have technology. Back in the days when I took class, I had to do this by hand. As you can imagine, it was highly annoying because it was a bunch of arithmetic. So be thankful we have calculators that do this for us now. So again, just like usually when we need the standard deviation, we can use one-var stats to find the standard deviation. Again, we put the values of the discrete random variable in L1 and the probabilities in L2, just like finding the mean that we did a couple videos ago. And we put L1 where it says list in the one-var stats, and we put L2 for the frequency list in the one-var stats. So the TI-84 only gives us sigma x when the sum of what's in list 2 is 1. That's because a probability distribution for a discrete random variable is considered a population. So if you noticed, for the mean, we used mu, and remember mu is a population parameter. So the same thing, we use sigma with a subscript of a capital X to tell us that we're finding the standard deviation of a random variable and its probability distribution. So if we go back to our shoe sizes from before, we should be able to get the standard deviation. Hopefully you did not clear that out. I have my screen right here. So if you notice, before when we found the standard deviation in chapter 3, when we were finding the standard deviation of a sample, we had a value for Sx because S is for a sample standard deviation. This time we only have sigma x again because we have a population here. So our standard deviation is 3.73. Let's just round to 2 decimal places. Remember, Pearson will tell you how many to round to normally. So, using one-var stats, and remember we get to that by the stat button, and then calc, and then one-var stats, and remember list was L1, frequency list was L2, and remember that was shoe size in L1 and probabilities in L2. We get that the standard deviation is 3.73. So, how do we find the variance? Remember, for the variance, we square the standard deviation. So, that is sigma x squared. So you can do this one of two ways. We really, to get the variance, should type this whole number in the calculator in order to avoid a rounding error. Or we can do this. You can hit, after you've done the one var stats, you can hit the vars key, pick number 5 for statistics, and we want, remember the variance is just the standard deviation squared, so we want to pick number 4, and then hit the little x squared button over here on the left-hand side, about halfway up the keys. And then hit enter, and so we get 13.88. So our variance is 88 or 89? I may have misread that. 13.88. And that is our variance. Okay, now let's do a couple problems. All right, let's do the extra practice. So an investment counselor calls with a hot stock tip. He believes that if the economy remains strong, the investment will result in a profit of $50,000. If the economy grows at a moderate pace, the investment will result in a profit of $10,000. However, if the economy goes into recession, the investment will result in a loss of $50,000. You contact an economist who believes there is a 20% probability the economy will remain strong, a 70% probability the economy will grow at a moderate pace, and a 10% probability the economy will slip into recession. What is the expected profit from the investment? Well, first we need to make our probability distribution. X is going to be our profit. That's the value of the random variable. And of course, then we have our probabilities. So we have 3 options. Either we're going to make $50,000, we're going to make $10,000, or we're going to lose $50,000. So we make $50,000 if the economy remains strong, and there's a 20% probability of that, which is 0.20. Remember, we always have to turn our percents into decimals. There is a 70% probability that the economy will grow at a moderate pace, which means we make $10,000. And there's a 10% probability the economy is going to tank. And if that happens, remember, we lose $50,000. So we do one var stats, and we do that with list being list 1, which is our X, and list 2, our P of X. And I'm not going to do that again. You can go back and watch previous videos in this section if you need to remember how to do that. And so we come up with the mean of this random variable probability distribution is $12,000. So the expected profit from this investment is $12,000. Okay, I don't think we have time to get this second problem done in this video, so we will pick it up in the last video for this section.